Okay, so today we're going to be looking at the Taylor polynomial approximation. So we see this example, and f of x is equal sine of x. So this is one of the functions I said you'd see most likely on the AP exam. And this is a third degree. So n in this case is 3. And sometimes we write our polynomial p sub n of x. So in this case, we have p sub 3 of x. And this is a Taylor polynomial. You can also write it as t sub n of x. So whichever works for you. Now, in this particular case, it is a Taylor polynomial because we're saying about when x is pi over 2. This is our center. Okay? And if our center is, let's say, x equals 0, then you would say it's the Maclaurin series that we're using. But when the center is something else like pi over 2, definitely, this is just our general Taylor series that we're going to use. And we're going to use the polynomial that we get from our series to do this approximation. So let's get started. Okay, if you didn't get the example done the last time, I'm going to read it through, and you're going to be able to copy it down as I do. Let f of x equals the sine of x. Okay. Write the third degree Taylor polynomial for f at x equals pi over 2. So once again, that's our center. They have to tell you that. The degree to which you're going to work up to, they need to tell you, so you can write out the polynomial. Okay, so our polynomial is going to be p of x. We're going to write p sub 3 of x here. And we're going to be using the function sine of x equals f of x. So if it's centered at pi over 2, okay, a sub 0 turned out to be like f of our center. So it's going to be f of pi over 2. Then we're going to add where we need our first derivative. So f prime of pi over 2. This is going to be multiplied by x minus pi over 2 to the first power. And this would be divided by 1 factorial. By the way, this is divided by 0 factorial. So because 0 factorial and 1 factorial are 1, we typically do not need to write that there. But if it helps you keep a place value of where you're working, then that's fine. You can keep it. So our third term, because we only have 2 and we need to work up to our third term and our fourth. So let's keep going here. So we end up with, we need f double prime, and I read a space there, believe it or not, pi over 2 times the quantity of x minus pi over 2 squared over 2 factorial. And last but not least, we need f triple prime of pi over 2 times the quantity of x minus pi over 2 cubed, okay, over 3 factorial. Okay, I would definitely leave the 2 factorial as 2 factorial instead of 2, which is its equivalent, because that's usually what we see on the AP exam. And 3 factorial, just leave it as 3 factorial instead of 6. So what we need to do at this point, if we're not going to change those, is actually figure out what all our derivatives are and plug in pi over 2. So we know f. We need to know f prime. Okay, so f prime of x would be cosine of x. Okay, we need to know f double prime of x. That would be negative sine of x. And we need to know f triple prime, or our third derivative of f, and that's going to be negative cosine of x. Okay, so now f of pi over 2 is going to be the sine of pi over 2, and that is 1. So we're just going to write 1 for the first term. Now, f prime of pi over 2, we have to figure out. It's the cosine of pi over 2, which is 0. So all of this in our next term is just going to be 0. If you want, you could write 0, but I would just go to the next expression, okay, which is over here. Figure out what this is. So I need to know what f double prime of pi over 2 is. So it's a negative sine of pi over 2. Well, the sine of pi over 2 is 1, so if I negate that, I get negative 1. So I'm going to erase this plus sign because I'm going to have a negative 1 times the quantity of x minus pi over 2 squared over 2 factorial. Okay, so this is starting to be my answer. It's a little unclear because of like the lines. I have to try to rewrite this for you so it's a little bit clearer. I apologize about that. So maybe this, yeah, this looks so much better. Okay, so now we got to continue and do this part. So if we plug in pi over 2 for x, okay, well, once again, cosine of pi over 2 is 0. So even if I try to negate it, I'm going to have 0 times x minus pi over 2 cubed over 3 factorial. This is just going to be 0. So I'm going to end up with this expression, whether it was a second degree Taylor polynomial or a third degree Taylor polynomial, because I'm adding 0 there. So what do we end up with? Okay, so if you think about what the curve for f of x is, sine of x, okay, and it's centered at pi over 2, so what we're creating is a parabola that opens downward, and I did not draw that very well, but if you look at our expression, this makes sense. Okay, so there's sine, there is the parabola that opens downward, there's our center, there's 1, that would be pi over 2. And so this is a really good approximation for a curve as long as it's near our center. Okay, so that's why it's so important to have that there. Now, as you can tell, I was kind of making a neat kind of expression here for all our work. Sometimes they're not giving you the function, but they give you a table with all of these answers. So you have to know to plug in, you know, what numbers belong where in order to write your function, as we have over here. Okay, so this is our answer for our example. Other problems may be slightly different, but you're essentially doing the same thing. So just kind of keep that in mind and be neat about finding your answers, and you should be good to go. So good luck. Have fun. Ask questions if you need to, and have fun on the practice.